One day, instead of doing my trig homework, my mind wandered to this. 5 and 5 is 10, and 6 and 4 is also 10. But 5 times 5 is 25, while 6 times 4 is only 24. I wondered why there was a difference. So I considered the other combinations that added up to 10, and when I put them in the right order, then I realized that the differences looked like the series of odds, starting with 1 at the middle, and each next step took the next odd. So to check if I was right, I wrote down the next few combinations, and saw that the pattern continued. And then I thought, I wonder if knowing this pattern can help predict an answer in multiplication. So I moved up to 10 times 10, since zeros are easy, and thought, what if I didn't know the answer to 11 times 9, but I did know how far it was from 10 times 10? Since it's only one step out, it should be only one odd less. And sure enough, taking 1 away from 10 times 10 gave the answer. And then I thought, if 12 times 8 is 2 steps out from the middle, then it should be 2 odds less than the middle. And it was. And I figured 22 times 18 is also 2 steps out from the middle, so it should also be 2 odds less than the middle. And it was. And I thought, what if instead of using the middle to solve, I'm actually solving for the middle, using something that lies outward from it? When I saw that this answer just happened to be 2 odds away again, I thought, whenever using a replacement problem that lies inward, you subtract the adjustment, and when using a replacement problem that lies outward, you add the adjustment. I tried 22 times 17, thinking since it's 2 steps out from the middle, it should be 2 odds less than the middle, and it wasn't. Out of random curiosity, I thought of adjusting by evens instead of odds, and even though it was problem solved, my simplicity ride was over, because in addition to knowing whether to add or subtract the adjustment, now I had to keep track of whether to adjust by evens or odds. If this kind of replacement multiplication was going to be helpful, I needed an easy way to tell the difference. I had noticed that when the difference between the multipliers was even, I could adjust by odds, and when it was odd, I could adjust by evens. And I also noticed that when the difference between them was odd, it was because the middle numbers were not the same number, but they were 2 different numbers. But this all seemed to complicate things, not simplify them, so I decided to find the reason that it complicated things and work in the opposite direction. So I tried 28 times 22, and I saw that since the difference was even, I would adjust by odds, and I also saw that since these multipliers were already 3 steps out from the middle, then the adjustment would involve the 4th and 5th odds. And that's when I realized the fact that I didn't know which evens or odds to adjust by unless I knew how many steps they were from the middle, and that was exactly the problem. And it was about to become a much bigger problem if I had multipliers which were farther apart, because the truth was that neither the replacement nor the solution necessarily had anything to do with the middle. So if I was to work in the opposite direction, I would have to find a way to not need the middle numbers. What I would look for was a way to bypass this step and know their sum without having to consider the middle at all. What I needed was an equation. I knew that whether by subtracting each of these or subtracting their sum, the adjustment should come out to be the same. I also saw that the sum of these 2 odds came out to be the exact same thing as doubling something else. I also saw that combining these 3 odds came out to be the same thing as tripling something else, combining these 4 was the same thing as quadrupling something, and combining these 5 was the same thing as quintupling something. So knowing that 2 steps would double something, 3 steps would triple something, 4 steps would quadruple something, and 5 steps would quintuple something, I knew that my new equation would include an s for the number of steps to be multiplied by something. I also felt kind of saved by the bell when I realized that none of these types of multiplication problems would ever require more than 5 steps. So now the trick would be knowing exactly what to double, triple, quadruple, or quintuple. I noticed that this something was 2 less than the difference between multipliers, and that was the number of steps. It was much easier to see the difference between multipliers than it was to see how they related to the middle. I noticed that this was 3 less than the difference, this was 4 less than the difference, and this was 5 less than the difference, so it appeared that the something element within each of these was exactly the number of steps less than the difference between multipliers. Now that that was in place, my new equation was ready for a test run. So I moved back to smaller numbers that I expected it to work on, and it worked. Then I tried mixing it up by changing the direction of the steps, and it didn't work out anymore. But it was an easy fix, and a familiar one too. For a while it seemed that this could become intuitive enough, but soon I started to have the feeling that I was missing something really obvious. I ran over the numbers with this equation for hours, and then one day my dad casually said, "Doesn't that just give you the product of how far each number is from 0 or something like that?" And I thought it was funny that he said, "or something like that," because it turns out that's exactly what it was. My equation only provided the product of how far each number was from its closest 0. So I practiced this pattern. Eventually this pattern became how I checked my multiplication, because for these types of problems I wasn't using the traditional algorithm anymore. but there was still a problem. The truth was that this principle only worked because I was relating these amounts to each other, not to any particular digits.